Hello, everyone. I'm Pali Bhatt, VP of Product and Design at Google Cloud, and I'd like to welcome you to Google Cloud's Container Security Building Trust in Your Software Supply Chain event. Today, we're focusing on a very important topic that's made national headlines and even prompted an executive order from the President of the United States. So, what exactly is a software supply chain? Simply put, it's a journey of code, configuration files, deployment specs, all of the things that we call artifacts that make up your product or service on the path to production. This journey is analogous to a manufacturing supply chain. The car you drive, for instance, is made up of thousands of parts from hundreds of suppliers. Likewise, software products often leverage dependencies from hundreds of third parties. Next, just like your car parts are shipped and stored in warehouses before they make it into your car, software dependencies are stored in repositories or repos. Finally, just like your car is assembled from parts before it hits the showroom floor, your dependencies combine with your code in a CI/CD pipeline before customers can access your products or service. As you can imagine, each link in the supply chain, whether it's manufacturing or software, is susceptible to security compromise. Increasingly, these links in the software security supply chain have also become common vectors for attacks for two main reasons. First, while open source software has enabled incredible innovation, it also means that we are now trusting external supply chains, including unknown contributors. So, understanding your dependencies and if any vulnerabilities exist in those dependencies can be extremely difficult. It's not surprising that 2020 saw a 430% surge in open source supply chain attacks, and an estimated 84% of all commercial code bases have at least one open source vulnerability present in them. Second, as deployment velocity has risen, legacy security practices are no longer viable. Take, for example, the transition from VMs and monolithic architectures to microservices. It comes with an increased number of components being deployed independently, each created by their own supply chains and released at their own cadence. For instance, internally at Google, we launch several billion containers per week. It's not surprising that high profile hacks like SolarWinds, Minecast, and CodeCov have preyed on this increased velocity and open source dependence. In the case of SolarWinds, for instance, a third party dependency was used as a vector to deliver malware during a software update. These attacks highlight how this is not just a theoretical threat, but a real one. In fact, the threat is so imminent and impactful that President Biden has recently issued an executive order requiring all federal suppliers and critical utilities conform to forthcoming software supply chain security standards. And we believe that these new standards will quickly become broad norms across the entire software industry. So the time is now for to understand and plan for securing your software supply chain. So, to help us dig into these issues, we have an amazing panel today. Please join me in welcoming Eric Brewer, VP and Google Fellow, Phil Venables, Chief Information Security Officer at Google Cloud, and Shane Lawrence, Staff Infrastructure Security Engineer at Shopify. So, let's start with President Biden's executive order that we talked about earlier. Phil, what does it say and what does it mean for the software industry?
Yeah, so we've been working on this quite a lot since the administration announced it, and there's a number of different elements in the executive order that range from things like stipulating the need for zero trust architectures, requiring government agencies and contractors to operate a whole process around assuring a secure software supply chain, instigating a cyber safety review board to look at incidents, and in fact, working on a broader playbook for examining and managing cybersecurity vulnerabilities and incidents. But when you take a step back from those kind of broad themes, the real big positive part of this, which I think a lot of us in the industry have been very welcoming of, is this framing around the need for IT modernization as a necessary approach for cybersecurity. There's been a lot of kind of government edicts in the past that have been very much about requiring cybersecurity investment. And often, if as I think a lot of the audience will know, if you just invest in cyber and don't invest in your broader technology infrastructure and application infrastructure, it's like building on a foundation of sand. And one of the things that was very refreshing in the EO was, in the executive order, was just how it pushed government agencies and their contractors to start thinking about what they need to do to modernize their IT to support effective cybersecurity. And a big part of that again is looking at the underlying software supply chain and the foundational controls that come as part of zero trust. And this is something that we at Google, I think a lot of people will know, are very familiar with, since we kind of set the stage for a lot of that work in a lot of the work we did on Beyond Core and then Beyond Prod. And again, we've been very much in the process with the White House, with NIST, and with the NTIA as part of the standards setting process, to provide our expertise and our capability and kind of our thoughts on the process into that. So overall, we view this in a very positive way, and I think it's ultimately going to see a lot of transformation for the industry, especially as the standards emerge from NIST and NTIA around what I think even the companies that are not necessarily in the scope of the EO are probably going to adopt, because it's all going to be very useful standards.
Thanks, Phil. And the executive orders seem to be, at least in part, a response to the increase in sophisticated and malicious supply chain attacks. So, Eric, given your deep expertise in this area, could you share a little bit more about what types of attack vectors were used and what we can learn from them?
Well, actually, the first thing I would say is the attacks are complicated, but we found kind of 8 different places that you can attack as part of the supply chain, and all 8 have to be secured. So we call this kind of our map, and it walks through. You need to secure your source code. You need to have a secure build process. You have a lot of dependencies, both open source and not. They're hard to manage. Then when you deploy things, is it actually what you meant to deploy? So it's a lot of steps here. And unfortunately, you really have to prevent attacks on all these vectors. If you look at what happened recently with both SolarWinds and CodeCov, multiple attack points were actually used. I think CodeCov used 4 of these different attack points.
Phil, can you share a little bit more about how Google's securing its own software supply chain internally?
Yeah, so as you can imagine, at our scale, and our kind of operating the scale of infrastructure and services that support multiple billion users plus services, we have significant capabilities and have taken a long-standing and quite serious approach to this for a long time. And so, when you look at not just how we manage our software supply chain, but our infrastructure overall has operated in this zero trust manner for a long time. And our software is built in a controlled environment. And when you look at what Eric just went through, when you think about all of the control steps in that supply chain, we've spent a lot of time investing in our own internal capabilities that make sure our software is managed in a central way. There's dual control over software changes. The software is reviewed. It's run through a secure build process. Some of the external inputs into those builds are copied and run in our environment, and vulnerabilities resolved in those before they make it into our process. And then also the output of that software build process results in signed artifacts that are internal container runtime will only execute if it's emanated from that secure build process. And the great thing about this, a lot of these elements that we've built internally in Google have made their way into a lot of our cloud products, particularly around our kind of Anthos and GKE platforms. When you look at what we do with binary authorization, you look at some of the work we've done in terms of container security, and increasingly, as we develop more and more of these capabilities, we're looking to put them in the hands of customers so that everybody can benefit from these approaches. And similarly, we continue to do a lot of work with the standards community, the open source community, and others to make these capabilities available, not just in products, but also as part of just the way the industry is approaching these things. And that's something we're going to continue to spend a lot of effort on as well.
Thanks, Phil. And Eric, can you share a little bit more about how the whole community can benefit from all of the things that Google has learned over like 2 decades of doing this at scale?
Well, yeah, the good news is we have a supply chain solution in house that works very well and is kind of tested in production. The bad news is that you can't exactly externalize that as is. And so, what we've done instead is define Salsa, which is a kind of a tiered approach to how you can improve your supply chain in steps. So the idea of SOS is here's all the things you actually have to do to have a secure supply chain. But because there's a lot of steps and a lot of attack vectors, you don't do them all at once. So it's like kind of SOS level one is kind of just get a basic process where you can build things that are signed and you know what you're building and you know what source code you're using. And then when you get to the higher levels of SALSA 2 and 3, then you actually start to get real security out of these systems. And you can actually trust that the software you're running is what you really meant it to be, and that you know what risks you're taking when you run it. So this is kind of a proposal to the industry of how we think the whole space should be solved. And it's, for feedback. And we'll work with the open source community in particular on how to make Salsa something that's easy to use. And of course, we'll also make it part of Google products, because I really believe these are all the things any customer needs to do to have a secure supply chain.
Thanks, Eric. And that's certainly the case, right? We are hearing more and more teams take advantage of open source. One of the interesting things that I've noticed is that Google conducts an annual DevOps survey called DORA, and we're seeing that many teams are starting to take more advantage of open source, and that so that they can get like a better velocity within their own teams. So can you share a little bit more about like how Google's making open source more secure, given how important it is for all of our customers as well?
Well, we became aware of some of these supply chain issues more than 2 years ago, part through the popularity of Kubernetes and GKE, where we could kind of really see that Kubernetes uses thousands of packages, and some of them are, well maintained and secure, and some of them are not. And that's a problem the whole industry faces. So we co-founded the Open Source Security Foundation in 2019, and that is purpose of that foundation really is to address security issues in open source, and very timely that it predates all these problems. So that's the foundation we expect to have the biggest impact in this space and represent the industry. And then there's a lot of individual things we do, such as Open Source Insights, which is a tool you can play with at deps.dev. What it allows you to do is see for your code what dependencies you're using from open source and what vulnerabilities they have. And that sounds like it might be trivial, but it turns out when you have thousands of dependencies and they're actually nested many levels deep, it's very hard to know what vulnerabilities are actually affecting your code. And Open Source Insights gives you that insight through its webpage. So that's the second kind of work we do with open source, actual projects. And there's many of those. We've open source vulnerabilities, lots of pieces, scorecards, which help you evaluate which projects have good security hygiene. But the final category is really just funding. So Google funds a lot of open source projects, both kind of classically things like the Linux kernel and its security, but also things like, well, we'd really like Rust to work in the kernel. So we funded ISRG to do that work. And we fund Python teams to do improved security for Python. So all these pieces work together to try to get a kind of holistic approach to how we're going to improve security for not just Google, and not just our customers, but really all of modern computing.
Thank you, Eric. And let's actually switch a little bit to Shane. Shane, could you share a little bit about how Shopify leverages open source and how you think about securing open source?
Yeah, of course. Shopify leverages a ton of open source. So our development in Ruby and Go and React are all open. And our infrastructure runs on Kubernetes, which of course is open source and has tons of dependencies that are also open source. We try to invest in open source too. So by giving back, we contribute to those projects as well as some of our own, like Crane, which gives us predictable deployments and allows templating, and things like Kubeaudit, which tells us if there are potentially dangerous misconfigurations in our Kubernetes manifests. And then we've also worked a lot on a thing called Voucher. Now, this was a close collaboration with Google, and it's fully open source. And its purpose is to give build time image provenance attestation. And what this means is essentially we have an authoritative way of saying, for sure, we built this thing with our own tooling on our own systems. And this is really important because once you've got this, you can use binary authorization to determine if this was actually built by us. And if it was, it just lets it deploy into production. But if it wasn't, you have an opportunity to stop it right there. So, in order to secure all of this open source, we need layers of checks and balances. And the goal, of course, is to prevent any attack from being successful, but we need additional safeguards too, so that if anything is compromised, it can't be escalated or allowed traversal to any other systems. So, securing our software supply chain starts with securing our own software. Now, we try to do this with paved roads, and I think this is the best way to ensure that we have secure software because our developers don't need to become security experts. We just give them sane defaults and a safe way of doing things so that the easy way is the secure way. Once we have that, we need to put in some guardrails too. There are always going to be certain workloads that need additional privileges, especially for infrastructure. And we need to make sure that something pops up to tell these developers that what they're doing, if it requires additional privileges, could be unsafe. And that way, whenever someone escalates this, it's always a deliberate choice. It doesn't happen by accident. And so we also make sure that within our own community, all of our work gets vetted, and this will protect against, any kind of malicious action by an employee or a stolen laptop or that kind of an attack. Because everything that gets committed to our repos needs to be vetted by somebody else at Shopify, and we do this with guardrails by enforcing PR checks. And not only can they see what's changed in the code, but they also get to see the result of whatever tests we're running in CI. To add to that, we do static analysis, and this happens at many levels as well. So it's done on the code, it's done on the config. We use various linters, and we also use a bunch of our own scripts to do this. I think which specific products you use is less important than making sure that you are practicing good hygiene on this code and the config files that go with it. And then once we get to build time, you've got this image. You need to make sure that, again, with Voucher, you've attested that you really created this thing. And then we use GCR image scanner to make sure that it doesn't have any vulnerabilities we might have missed. We use another tool called Dependabot to make sure that all of the upstream dependencies that went into that were up to date, because patching is really important, and this helps to keep our developers on top of it. Once we've got it ready to deploy, binary authorization ensures that it was attested by Voucher. And then once it's running in your production environment, we get sort of one last opportunity to detect anything that might be amiss. So we use open source Falco. Again, the specific tool is less important than that you are watching for this kind of thing. But if there's an ODay out there that we don't have any signatures for, that no one's detected yet, there's still one last chance using the runtime scanner, which looks at the syscalls at the kernel level to see if anything suspicious is happening and tell us about that.
So Shane, sounds like y'all have really spent a really good amount of thought in figuring out your software supply chain and how to secure it. So sometimes we hear about this trade-off between speed and security. So could you just share a little bit about the speed at which Shopify operates, and also share with our viewers like how speed and security can actually be complementary?
Yeah, of course. I don't think that there is a trade off between speed and security. When I started at Shopify 4 years ago, we had just started using GKE. We had a few clusters. Now we've got more than 250 clusters. We've got 45,000 services, and we've got runtime and deployment measures that need to be fast. So while all of this security stuff is happening, our developers can't wait. Our merchants aren't going to stop and wait for security to happen. So we need to make sure that this is happening in real time, and it needs to be performant. When we merge 1,300 PRs a day, there's got to be some kind of checks here that need to happen without disrupting anyone's workflow. So we might not be Google's size, but we're scaling really fast. And I think we've shown that you can have security and performance and scalability, and you have to have those things. It's not a trade-off. You need to have all of them.
Yeah, it's certainly the case, and thank you for sharing your insights. So to close, I think it'd be great if y'all could each share one recommendation to all of our viewers on where do they begin to start securing their software supply chain. So maybe Shane, we can start with you.
Sure. So just to be clear, where you begin is a little bit arbitrary. There's no panacea. There's no one thing that's going to solve all of your problems. And also there's really no one thing that's more important, in my opinion, than all of the other things that you could be doing. Because if you really neglect some of the other things, but do a great job on one, of course, you're not going to be secure. So, in a broader context, I think it's probably most important to just patch your software. If you have deployed things into your production environment with known vulnerabilities, you've done the attacker's job for them, and it doesn't matter how much you secure your software supply chain from that point because they've already got a way in. But for this audience, let's assume you're already on top of patching, and you want to be able to control your software supply chain itself. So I think a good starting point is begin with taking control of what's running in your environment. When you're able to assert that what you're running really came from your build tools or trusted repositories, then you have the opportunity to prevent things from sneaking in there maliciously, or even by a developer who maybe just deployed something they didn't realize was unsafe. And once you've got that in place, it gives you this really great foundation because you can only build upward from there. So you can add additional checks to make sure that you have things like it passed all of your CI tests, or that it came from a trusted repository, or that it passed that GCR image scanning. And once you've got all those, you can just continue to build on that. So I think starting with binary authorization is a really good foundation for everything else.
Thanks, Shane. And similarly, Phil, one recommendation that you might have?
Yeah, so we've talked a lot in this session about the software that companies produce and what software, whether it's other software or open source software that you embed in and distribute into your own products. And the one thing I would also add, though, is, as I think everybody would expect, most organizations also deploy pre-packaged software from vendors into their environment, whether that's from large IT vendors or small support vendors. And so one of the things that's been an emerging fairly common pattern is the supply chains of those product vendors being compromised to be used as a conduit for their software to then be used in their target customer deployments, whether it's for ransomware or other types of access. And so one of the things I think everybody should be especially careful of is these third-party vendor packages that you run in your environment that have quite high degrees of privilege, either because they're a system management product, a network management product, or other type of product. In some cases, a security product that, by definition, often has to have some quite high privileges to operate. To really kind of focus on some of those packages, and then go to those vendors and move beyond what might be their kind of boilerplate statement about their levels of security that provide a degree of assurance about the packages they're giving you. And maybe to the point of some of the stuff that Eric covered, maybe ask them just what their salsa level of conformance is in their software development processes, and then ultimately whether that particular company or you are in scope for what has come out of the executive order on software supply chain risk, is maybe use some of those NIST and NTIA standards to start asking pointed questions to vendors about whether they're appropriately securing and protecting what you're having to run with privilege inside your environment. So again, not just think about your own software, but think about the packages you're deploying and running with privilege as well.
That's great counsel. Thank you, Phil. Eric, for your recommendation.
Well, those are two very complete answers, so I don't have a whole lot to add. But I would say one pattern I see all the time that's easy to fix is have a private copy of your source code. If you're using open source, don't pull it off the internet and build from that. It could have changed at any time, right? So every open source package we use at Google, we have a private copy. We keep patches on it so that we know what vulnerabilities might be there, or if they've been fixed or not. And at least now we have a clean place to start for everything we build, where we're 100% sure where the source code came from and what state it's in. So that's probably step one out of many steps, as Shane said, that you're going to need to take. But that's a good and relatively easy one.
Awesome. Like really actionable. So Shane, you said like patch your software. Phil said, hey, make sure you think about your vendors as well, not just your own code. And then Eric said, like, hey, you know what? All you need to do is start by like making sure that you've got like all of your software under control. So you start off by thinking about all of your software, think about salsa, etc. Great sets of insights. Thank you, Phil, Eric, and Shane. I really appreciate it. And this gives me the perfect lead in to welcome Aparna Sinha, who's our Director of Product Management at Google Cloud, to talk about Google Cloud can help you proactively meet all of these emerging software supply chain challenges.
Thank you, Polly. Hi, everyone. I'm Aparna Sinha. As we've just heard, the threat from supply chain security is real, and it affects all of us. You don't have to be a bank or the US government to be the weak link. If you use software as part of your product offering, your users could be at risk, and that deserves your attention. So, how can Google Cloud help you? It's well known that using managed cloud services like serverless containers or managed databases enables higher developer productivity. But actually, these services also offer some protections against software supply chain risks. This is because Google has built security into every layer of our infrastructure and also into our internal software supply chain. It starts from the physical security of our data centers and our hardware, to software and data protections, to the secure internet communications and support operations. This is why Google's managed services help your overall security posture. But aside from using these managed services, it's also really important to secure the software that you create from general supply chain threats. So how do we do that? Securing your software requires establishing, verifying, and maintaining a chain of trust to establish the provenance, also known as the origin of your code. And this is done via attestations that are generated and checked throughout the software development and deployment process. This is just like we do internally at Google in our development process. And it enables a level of ambient security through things like code review, verified code provenance, and policy enforcement. All of this minimizes software supply chain and related risks, and it goes hand in hand with improved developer productivity. So as a Google Cloud customer, your secure software supply chain would look something like this. At the base, we have common secure infrastructure services like identity and access management and audit logging. Fortunately, most cloud developers already widely use these. Next, we secure your software supply chain with a way to define, check, and enforce attestations across your software lifecycle. This is super important. A key element here is our binary authorization service, which establishes, verifies, and maintains that chain of trust via attestations and policy checks. Essentially, cryptographic signatures are generated as code and other artifacts move towards production. And then, before deployment, these attestations are checked based on policies. So let me walk you through the steps of how to achieve ambient security in your development process through policies and provenance on Google Cloud. The first step is to understand your supply, or what libraries and frameworks you are using to write your code. As you know, open source is heavily used in all software, and it can be very challenging to determine the risk of your open source dependencies. So to assist with this, we recently launched Open Source Insights, which is an interactive visualization site for exploring these open source packages. Open Source Insights is actually quite unique because it provides a transitive dependency graph. So you see your dependencies and their dependencies and then dependencies of theirs. And it's continuously updated with security advisory, licensing information, and other security data across multiple languages, all in one place. So this really helps with polyglot applications. When used in conjunction with open source scorecards, which are a risk score for open source projects, Open Source Insights can be very helpful to developers to help them make better choices across the millions of open source packages they may or may not know they're using. So once you understand your dependencies, and once your code is checked in, it is built by Cloud Build. Here, another set of attestations are captured, adding to your overall chain of trust. Examples include what tests were run, what build tools and processes were used, etc. Notably, Cloud Build today helps with achieving a SALSA Level 1. Recall that SALSA is a standard that denotes the level of security of your software supply chain. Cloud Build captures the source of the build configuration, and this can be used to validate that your build was scripted. Scripted builds are more secure than manual builds and are a requirement for SALSA Level 1 achievement. Also, as required, this provenance and other attestations can be looked up using the Container Image Digest. The Image Digest is a unique signature for any image. So with those two things, Cloud Build achieves SALSA Level 1. Now, Cloud Build is a fully managed Google Cloud service. And as mentioned before, this means that in addition to developer agility, this service gives you a lockdown environment. And that greatly reduces the risk of compromised build integrity or a compromised build system. Security-conscious customers, of course, will want to ensure that they can enforce a security perimeter within their private network to keep data and access private. That's why today I'm excited to announce the availability of Cloud Build private pools in GA. With private pools, Cloud Build also adds support for VPC service controls and private IPs. This is great because now you can leverage the advantages of this lockdown serverless build environment within your own private perimeter. Going back to the supply chain, once the build is complete, it is stored in Google Cloud's artifact registry, where it is automatically scanned for vulnerabilities. This step generates additional metadata, including an attestation for whether an artifact's vulnerability results meet certain security thresholds. This information is then stored in our analysis service, which structures and organizes the artifact's metadata, making it readily accessible to binary authorization. Next, having built, stored, and scanned the images securely, we are ready to deploy. At this point, attestations captured along the supply chain are verified for authenticity by binary authorization. In enforcement mode, the image is deployed only when the attestations meet your organization's policies. In audit mode, policy violations are logged and trigger alerts. Binary authorization is available for GKE and Cloud Run, ensuring that only properly reviewed and authorized code gets deployed. Verification doesn't stop at deployment. Today, I'm also happy to announce binary authorization now supports continuous validation. This allows for continued conformance to the defined policy, even post-deployment. So, if a running application falls out of conformance with an existing or newly added policy, an alert is created and logged. That was a bird's eye view of the current supply chain capabilities of Google Cloud. Now I'd like to invite my colleague Dustin Ingram to show you a demo of how everything we've discussed so far comes together.
Thanks, Aparna. I'm Dustin, a developer advocate for Google Cloud. I'm going to give a quick demo of how developers can use binary authorization with their Cloud Run applications. I'll take a standard CI/CD pipeline and configure it to add attestations to the container image it produces. By securely signing the artifacts created by our build pipeline and configuring Cloud Run to only deploy trusted artifacts, we can ensure that only artifacts from our pipeline are able to be deployed. So let's enable binary authorization. First step is to create a binary authorization attester. An attester is what is responsible for verifying an attestation. An attestation is a record that contains metadata about the image that's been digitally signed using a private cryptographic key. Let's give this a name. And I've gone ahead and created a Cloud KMS keyring and key to use here, but you can also use your own keys. So let's import that from Cloud KMS now. And we'll create the attester. Next, I'll edit the binary authorization policy. By default, the policy allows all images to be deployed, but we want to use the attester that we just created. So we'll edit policy, allow only images that have been approved by the following attesters, and we'll add the attester that we just created, my attester. And save. Finally, I'll enable binary authorization on the existing Cloud Run service. Go and enable it here. Now, Cloud Run will only be able to deploy images that have attestations created by this attester. The process of creating an attestation is also known as signing an image. The attestation is created by signing the image's unique digest. A signer can be a person who manually creates an attestation, or a signer can be an automated process. If we switch back to our cloudbuild.yaml file, we can see that I've added an extra step to our pipeline. This new step, create attestation, happens between the publish step and the deploy step. After a container image is built, an attestation can be created to affirm that whatever required activities were performed on that image, like regression tests, vulnerability scans, or anything else. It uses the attester and key we just created to create an attestation for the image that was just created, so that when the pipeline attempts to deploy this image to Cloud Run, the correct attestations are in place to satisfy the binary authorization policy. So let's commit this change and make our first deployment with binary authorization. We'll add the cloudbuild.yaml file that we changed, commit the changes, and we'll push. Let's review what's happening here. We've made a source change and we've pushed it to our source repository. Cloud Build is configured to automatically run on any push to the repository. When it detects a change to the source, it builds and tests the container and pushes it to the image registry. Since our pipeline finished successfully, it generates an attestation, securely signing the image with a private key. Finally, our pipeline attempts to deploy this image to Cloud Run. Before actually deploying the image into production, Cloud Run ensures that the binary authorization policy we've set has been fully satisfied. If all the attestations for an image are verified, binary authorization allows the image to be deployed. So we can see that our build pipeline has finished successfully, and we can visit our app and see that the version deployed is what we expected to be deployed. Now that we have a binary authorization in place, let's see what happens if we try to deploy an unauthorized image. We'll try to deploy locally again from Cloud Code without any attestations. We can see that Cloud Run has now blocked the deployment because it didn't find any attestations that were valid and signed by the attester we've configured. Now, our Cloud Run service will only accept images built as part of our pipeline. What if, for some reason, our pipeline isn't working and there's an emergency hotfix we need to get into production as soon as possible? For these types of situations, you can use break glass to bypass binary authorization enforcement and deploy an image that violates the policy. Let's break glass. So I'll navigate to the Cloud Run services console and we can see that it's failed the deployment. Go to that service, and we can see that Cloud Run says that our update has been rejected by the policy, but we have the option to break glass. We just need to provide a justification for why we're using break glass. And break glass. Now we can see that the deployment is rolling out. When you use break glass to deploy an image, any attestations are not required, but every time this happens, a break glass event is automatically logged to Cloud Audit logs. These logs can be used for administrators to review or to trigger other actions whenever break glass is used. To wrap up, we've seen how you can enable binary authorization for your Cloud Run applications, ensuring only trusted images are deployed, and how you can use break glass to bypass binary authorization when absolutely necessary. Back to you, Aparna.
Thank you, Dustin. That was a great demo, especially how untrusted images were automatically blocked when the attestations were not present. Now, as we look to the future, I want to point out that Google Cloud software supply chain security measures are shifting left. For example, we have 2 new capabilities that make it easier for developers to discover and fix security problems earlier in their software development cycle. First, I'm excited to announce that on-demand scanning is now generally available. Besides automated scanning in Artifact Registry, developers can now run scans anytime with a simple gcloud command. This is especially useful for scanning during local development, and that allows them to shift left because it's well before changes are merged. Second, fuzzing is now available in Go in preview. With fuzzing, developers can perform automated fuzz testing to catch security loopholes right within their IDE. In addition to shifting left using binary authorization and fully managed CI/CD services for a secure software supply chain, developers can improve their security posture and development velocity by selecting a secure container compute environment. In general, the more locked down and up-to-date the compute environment, the more secure it will be. As such, Cloud Functions and Cloud Run with serverless containers offers the most buttoned-down, secure compute runtime. You can focus on code, while the container or function instance runs in its own isolated sandbox, and any access outside that sandbox is mediated through identity and access management. Now, to further enhance your security posture, Cloud Functions now features native integrations with Cloud Secrets Manager. This lets you conveniently store API keys, passwords, certificates, and other sensitive data. Finally, for Kubernetes applications, GK Autopilot is highly differentiated, especially for security. Autopilot offers our most locked down and secure Kubernetes environment. Beyond managing node upgrades, GKE Autopilot automatically configures security features like shielded GKE nodes, secure boot, and workload identity. Also, Autopilot implements security best practices by blocking less safe features like external IPs and legacy authorization. So, in conclusion, the need to secure your software supply chain has never been greater. For you as an enterprise, this security doesn't have to come at the expense of developer velocity. And that's precisely why at Google Cloud, we're providing a set of managed services for the end-to-end process of developing and deploying software. We're making security ambient, such that it's quietly taken care of in the background, allowing your developers to go fast securely. Thank you for listening, and thank you, Dustin, for our demo. Now I'm going to pass it on to Brenna to share with you some of our deep dives on each area of supply chain and policy.
Hi, everyone. I'm Brenna Washington, Product Marketing Manager with Google Cloud. Those keynotes were amazing, and we have a packed agenda ahead of us, digging deeper into software supply chain security with Google Cloud. First, Nikki and Don will talk to us about securing the supply side of the equation. As we've heard today, third-party dependencies are an important part of almost every software product. We'll explore how to secure those dependencies with artifact registry and vulnerability scanning. Up next, David and Anthony will walk us through setting up a secure build process. They'll explore topics like securing access to your source code, running builds in a VPC, securely using secrets during the build process, and much, much more. Next, Xiaowen and Sandra will demonstrate how security, policy, and binary authorization can be used to secure deployed processes and keep runtime secure. And our final session will come from John and Abby, focusing on securing your Kubernetes configurations with policy as code, including how to add policy checks to each stage of your software lifecycle. Please stick around at the end for a live Q&A session featuring some of our keynote speakers and industry experts. Now, let's get started. Take it away, Nikki.